Okay, in lesson 2.11, we are going to be looking at quadratics in standard form. Previously, you looked at quadratics in vertex form. Vertex form is a good form for graphing. However, when it comes to solving quadratics, which is what we'll do later, it's good to be able to look at quadratics in standard form. So today we are going to identify what standard form is. We're also going to identify what the coefficients are, A and B, as well as C in standard form, and then we're going to practice converting from vertex to standard form. So below down here is an example of standard form, ax squared plus bx plus c. One thing that you'll notice is it has a squared, and if you remember in our previous lessons, anytime you have a exponent that is squared, that's your highest degree, is 2, then you know it is a quadratic. So there's different forms of quadratics, but the key is that you have a power of 2, that your highest power is 2. Okay, so let's explore that a little bit more. Let's look at our standard form. So all three of these quadratics, they're in standard form. And again, we know they are quadratics because they have the power of 2. Now remember that we can have a power of 2, but if we also had a power of 3 somewhere, these would no longer be quadratics. So our highest degree has to be 2. Okay, so in our first one, we need to identify the A, B, and C. Well, if I look up here, the A is always the coefficient in front of my x squared term. So even if these are out of order, I'm always going to pull the number that is in front of my x squared term. Well, if I look at this first one, I don't see a number. But if you remember, the number is always going to be 1 if you don't see a number. So, in this first example, this is a negative 1. So really I could write this as negative 1 x squared, and it would be the same thing. So our A value is going to be negative 1. Our B value right here is always the coefficient in front of the x term. Well, in front of the x term, I have a negative 6. And I have to be careful that I always pull the sign that's in front of the number as well. So I have a negative 6, that's my B value. And my C value is always my constant term. Notice that the C value here is by itself. It's not next to an x at all. So my C value is a plus 8 or a positive 8, and I can just write it as 8. So it's going to be important to be able to identify the A, B, and C values later when we use the quadratic formula to solve quadratics. It's also important in our next lesson where we will graph these because we need to be able to pull off certain coefficients in order to figure out what the vertex is. Okay, if you like, go ahead and pause the video and you guys try to find A, B, and C in the next two quadratics. Okay, so if you're coming back, let's see how you did. So our A value on this is going to be a 2, a positive 2. Our B value is 4, and our C value is negative 10. And notice these are all in order, so it works out very nicely. But always make sure that you remember that the A value is in front of the x squared, the B value is going to be in front of the x, and the C is your constant term. Okay, in the last one, our A value is 5. Oops, interesting, 5. Our B value is going to be, now hopefully you notice since there's nothing in front of the x, we can actually put a 1 in front of the x. We just have to be careful to pull off the sign too. So our B value is going to be negative 1. And our C value is our constant term, which is just 1. Okay, and that's how you find the A, B, and C from standard form of a quadratic. And one thing that I wanted to point out to you, and maybe you've already seen it, is if you think about standard form of a linear equation, and I'll write linear up here, it's all very similar. So the standard form of a linear equation is that ax plus by is equal to c. So again, very similar to a quadratic, except for there's no squared. Okay, so a is always with x, and b is always with the next term, and then you have c out here by itself. So c is always your constant. All right, let's look at converting from vertex form to standard form. So here's some steps that you might want to write down just to remind yourself. But really, if you think about PEMDAS, and you have parentheses, exponents, multiplication, division, and then addition, subtraction, it will help you to simplify, to convert from vertex to standard form. So if I look at this, remember this is in vertex form. And it's vertex form because my vertex is easily shown. So my vertex would be positive 3, comma, negative 1. But what I want to do is convert this to standard form. So the first thing I'm going to do is simplify, and I'm going to do exponents. Now I didn't do my parentheses because I can't do anything in the parentheses. X minus 3, those are not like terms, so I cannot combine them. So I'm going to go ahead and always do my exponents first here. So if I look, I have x minus 3 squared. So I have this binomial and I need to square it. So let's look at how we would do that. So what I have really is I have two of them. So I have x minus 3 times x minus 3. So this squared means I have 2 of whatever's in parentheses. So here's my 2. And the way that I want to combine these together to multiply them, notice there's 2 parentheses with nothing in between, so these are both being multiplied, is I'm going to distribute. And it's the same way that you would distribute just a 3 into the parentheses. This time you're going to distribute both the x and the 3. So what I like to do is start with the x, and I'm going to multiply the x into the other parentheses. I'm going to multiply it by x, and then I'm just going to go down the line. So then I'm going to multiply it by 3. When I'm done, I'm going to move on to the negative 3. So I'm going to take negative 3 times the x and negative 3 times the negative 3. So this isn't any different than how you would normally distribute. It's just that you have 2 numbers you're distributing into the parentheses instead of 1. So let's go ahead and do that. So we'll start with our x. X times x is going to give us x squared. X times negative 3 is going to give us a negative 3x. Okay, now I'm going to move on to the negative 3. So I have negative 3 times x, which is another negative 3x. And then I have negative 3 times negative 3 here. So that gives me positive 9. Okay, now that's still in parentheses because I haven't gotten rid of my parentheses. And then I have a minus 1 on the outside. Don't forget about that. Okay? So what I want to do now for step 2 is to distribute. Well, if I look in this situation, all I have to distribute is a 1 that was in front of the parentheses. So really, 1 times anything is just anything. So 1 times all this is just going to be x squared minus 3x plus 9 minus 1. So now my parentheses are in fact gone. So my final step is just going to be to simplify by combining like terms. Well, if I look at my like terms, this is where you have to be careful. I have an x squared term, but I don't have any other x squared terms. So that doesn't need to be combined with anything. But I do have a minus 3x here and a minus 3x here, and those are like terms. I will need to combine those like terms. Let's see what else I have. So if I look further down, I have a plus 9 and a minus 1. Those are both constant terms. Those are like terms, and I will need to combine those. So let's go ahead and do that. So I have my x squared term. It can't be combined with anything. A minus 3x minus a 3x is the same thing as adding a negative, right? So I can change this to a plus and a minus. So if I combine those together, I'm going to get a minus 6x. And then I have plus 9 and a minus 1. So that's 9 minus 1, which is just a positive 8. All right. So I am finished. What I have done is I have converted from vertex form to standard form. Now if I want to, just for practice, let's go ahead and identify our A, B, and C values. So let's find our A first. Well, our A term, remember, is always in front of the x squared, and there's nothing there, so that means there's actually a 1x squared there. Our B term is always in front of the x value, and then we have a negative 6 in front of that. And our c term is always the constant term, the term that's by itself, and that's an 8. All right, great. So let's do 2 more examples, and then you can try the practice that follows. Here's our next example, and if you'd like to go ahead and try this on your own first, go right ahead and then come back and see how you did. All right, so let's take this first one. Let's simplify by doing our exponents. So what we have is x plus 4 times another x plus 4, because we have x plus 4 squared. So we have 2 of them. So remember that we need to FOIL, some people call it, or distribute. So we're going to do this x term times this x, and the x term times 4. Then we'd move on to the 4 and do 4 times x, and we're going to do 4 times 4. Okay, so x times x is x squared. X times 4 is 4x. Then we move on to the 4. 4 times x is 4x again. And 4 times 4, and they're both positive, is 16. Okay, now when you're finished, remember to put the parentheses back on and put the rest of the equation in its proper place. So we have a plus 3 on the end, and there's a 2 out front. So we need to make sure that we leave that 2 out front. Okay? And there's our quadratic, but all we have done is we have gotten rid of the exponents by FOILing or distributing the 2 binomials together. Okay, so step 2 is to distribute. And what I'm going to do before I distribute is I'm going to combine my 4x terms together because it'll make it a little bit simpler when I distribute. I won't have to distribute to as many terms. So let's go ahead and combine those in this problem. So before we simplify, I'm going to rewrite this and make it a little bit simpler. So I've got the 2 still. I've got the x squared. 4x plus 4x gives me 8x. And then I still have the plus 16 on the end. And then outside of the parentheses, I've got the plus 30. Okay, now we can distribute. So this 2 distributes to every term in the parentheses. So when you distribute, you have to multiply the 2 times the x squared, the 2 times the 8x, and the 2 times the 16. So let's do that. So we would get y equals 2 times x squared is going to be 2x squared. 2 times 8 is 16x, because there's an x there, and 2 times 16 gives us 32. And then I can write the plus 3 on the end. Okay, great, we're almost done. All we need to do now is combine our like terms. So I have, on the end, I have a plus 32 and a plus 3. So that's basically 32 plus 3. That's all I have left to combine, since I combined my like terms in the parentheses up above. So my final answer is going to be y equals 2x squared plus 16x plus 35. All right, now let's just go ahead and identify the A, the B, and the C. So remember that the A term is in front of the x squared, so that's 2. The B is in front of the x, which is 16, and the C is our constant term, the term that's all by itself, and that's 35. Okay, final problem. So in example 3, here's our quadratic in vertex form. Let's go ahead and switch this to standard form. So again, if you'd like to go ahead and try this, give it a try and then come back and see how you did. So our first step is to simplify by getting rid of our exponents. So again, I have x minus 1 squared, which means I have 2 of them. So I have x minus 1 times x minus 1. And I need to distribute. So I'm going to multiply x times x and x times negative 1. Then I'm going to multiply negative 1 times x and negative 1 times negative 1. So when I do that, x times x is x squared. X times negative 1 just gives me negative 1x, or negative x, it's the same thing. Moving on to the negative 1 times x gives me negative 1x, or negative x, it's the same. And negative 1 times a negative 1 is a positive 1. Okay, now I'm going to throw my parentheses back on here, and I'm going to put the 7 at the end, can't get rid of that, and the negative 2 in the beginning. That's still there as well. Okay, so I've gotten rid of my exponents, and now I'm going to do what I did last time. I am going to combine like terms. So I've got a negative x and a negative x. So really what that means is I have a negative 1x, and I could change that to a plus, and then put the minus up here, and negative 1x. So what I'm going to do is combine those together. So what I'll have is y equals negative 2 x squared, and then a negative 1 plus a negative 1 gives me a negative 2x. And then I've still got the plus 1 and then the plus 7 on the end. Okay, again, notice how important it is to always rewrite everything completely and not to skip steps so we don't miss any of our numbers. Okay, now we can move on to step 2. Let's simplify by distributing. So we need to get rid of these parentheses, but we do have a negative 2 out here. So what I want to do is I want to multiply the negative 2 into the parentheses. So I'm going to multiply it by each of these terms. So I'm going to multiply negative 2 by x squared, negative 2 by negative 2x, and negative 2 by 1. So when I do that, I get y equals negative 2x squared. Negative times a negative is going to be a positive 4x. And then a negative 2 times 1 is negative 2. Now my parentheses are gone. So my final step, step 3, is to combine the like terms that are left. So I've got a negative 2 and a positive 7 that I can combine. So my final answer is y equals negative 2x squared plus 4x plus 5. And lastly, I just want to identify again my a, b, and c values because I'll use those in the future. So my a is going to be negative 2, b is going to be 4, and c is going to be 5. All right, and that concludes our lesson for today. So what you have learned out of today's lesson is how to identify standard form. This is what it looks like compared to vertex form. You've also learned how to identify the coefficients a and b, as well as the constant term c on the end. And you can also convert from vertex to standard form by simplifying, getting rid of the exponents, as well as the parentheses by distribution, and then finally to convert like terms. So go ahead and try the practice on your own on the next page.